All right, moving right along to the next session, which we are now late for. Gregory, I put you in charge of this session. This was the Calamari clients discussion, was getting a new name, as well as some discussion on how to implement high-level stories in an intelligent API. So this is all things Calamari. And Gregory, you want to give us a little bit of a background?
Yeah, totally. Thanks for the choice slot, Patrick. Coming right off the intro gives me a larger audience than usual. So for the first blueprint that I want to talk about is about the renaming of Calamari clients. So Calamari clients is a UI that utilizes the Calamari project to provide a visualization of a number of Ceph clusters. And we found since joining Red Hat that the naming of that does cause some confusion. Specifically, when you talk about, well, I'm working on Calamari, often people are confused about whether that's the API or the UI. So some time back, we started discussing changing the name in order to remove the confusion. And in the past couple months, another benefit from doing that has actually emerged also. So the idea here being that within Red Hat, we often have upstream projects and we try to commit to upstream first. So we're contributing to the community like good members of any open source project. And then we have downstream repositories that we build the products from. And so I saw the opportunity here to create an upstream repository for Calamari clients and rename it at the same time. And so yesterday, I went ahead and did that. I'm going to go ahead and share my screen with you guys. Just so you can see some of the things I'm talking about. All right. So this is the repository in question, Calamari clients, and I put up a README in my branch that I'm proposing to pull into the main thing. Basically, I'm just saying that we're changing the name of Calamari clients to Ramana. There's a link to Wikipedia describing what that means. But the more important is, what does it mean for you as a contributor to Calamari or Calamari clients? Well, it means nothing much from a lot of standpoints. Code's still going to be available under the same license as before. That's MIT. And it's going to still be developed in the same way. So anyone who contributes pull requests against the other repository, which isn't going away in the short term, I'll kindly move it over here and put it into this, the new upstream for the UI, the kind of reference implementation of what's available in the Calamari API.
The leader has muted your line. To unmute your line, press #6.
Hopefully I'm not muted.
You're not.
Good.
Great. So that's that. Just a little bit of trying to reduce confusion, trying to call out that this is explicitly the upstream, and it's also explicitly a reference implementation, and that any other UI could make similar benefit of using the Calamari API, and then to call out really that this Calamari, what I spend most of my time on is a RESTful controller of Ceph. It's an intelligent API that allows you to manage and monitor multiple Ceph clusters, and that when I talk about Calamari, this is what I'm talking about. And when I work here, I'd also like people to contribute to this specifically. The UI is a great way to help people understand quickly what we're doing, but actually all the intelligence, the smarts, and the blood, sweat, and tears goes into the API so that we have a clean separation and everybody in the community can benefit from this because it's a consistent way to interact with Ceph from a management perspective. So that's that. If there's questions or feedback, I'd love to hear it, but that's the plan going forward. And I'm going to switch over to talk about my other blueprints.
Before we move on, is there a plan for having releases of Ramana? And are those going to be in step with releases of Calamari, or is that going to be separate?
That's a great question, John. So the plan there is that we still have a product that's based on this, and we're still going to continue to add things where it makes sense. And so I think keeping it to be a vital project is important. And so I plan to make releases of the upstream in step with Calamari, so that the compatibility is not questioned and its vitality, there's still expectations from the community that any work that they put there will be available on a regular schedule. So the standing release schedule for Calamari right now trails Ceph by 1 month, and it's 3 times a year. So you can expect that there'll be at least 3 more releases of Romana this year. Does that answer your question?
Yeah, I think so. So we're expecting the first release of this to be about a month after Hammer. Is that right?
Yeah, I think that's fair to say.
Awesome.
All right, cool. So let me go ahead and talk about Calamari a little bit more. So the blueprint that I'm putting forward here is how to implement high-level stories in an intelligent API. And I'm going to try and do kind of a deep dive into the architecture of Calamari. There's been broad overviews of it before, and I know that there's videos available for that. Probably if you search for Calamari and John Spray, probably you'll find a friendly introduction to what Calamari is and kind of the overview of how it's put together. But my goal here is a little bit different. I'm going to show an existing feature and the points on the architecture where it touches, so that I can talk about a user story that isn't implemented and talk about how one might implement that and get feedback and maybe garner excitement for anyone who's interested in contributing along those lines. So as a disclaimer, I'm only speaking about the next feature as kind of this is how I think it could be designed, but there's nothing set in stone. Feel free to disagree with me if you like. So without further ado, I'm going to show you a little bit of video of using the Calamari API, and then I'm going to show the code that it touches and talk about some of the responsibilities of those components. So are you all able to see that? I just want to make sure that the full screen didn't kill the video.
I'm not seeing a screen share.
Okay, good. I'll have to make sure that I do that. There we go. How about now?
There it goes.
Great. Okay. So, this is a pre-recorded video of interaction with the Calamari API. Specifically, we're going to talk about pool creation and updates. And we're going to start off from a pool list view and go through kind of a story that sounds like, as an administrator of Calamari or of Ceph, I want to be able to expand pgnum on a pool without disrupting I/O. So imagine that we're setting up an RGW setup, and we need to create a couple pools for that. So I'm going to show you that I've already started by creating an RGW pool, which has a placement group number of 32, which is in line with our current recommendations. And I'm going to go ahead and create the next pool, RGW buckets. You can see that we've got a request ID. I'm going to go over to the request endpoint and start learning about what happened for that creation. You can see that at the top there, we're creating a pool, and we're waiting for a specific OSD map. And then after a short amount of time, it's going to succeed, and we can go back and look at the resource itself. So there, it's completed successfully. And if we go back and look at the list view and head down to the bottom, we can see that we made it. So here's the part where the update comes into play. We realized that, we created the pgnum far too low for what the current guidance is. So if you look on ceph.com pgcalc, it suggests for a use case like RGW and OpenStack combined on a Ceph cluster that we should be using a PG count much higher than what we just created. So we're going to use the update functionality of the API and show how this is part of what makes Calamari great, the idea that we can perform multiple Ceph transforms from one REST change. So I'll go back to the API here, and I'll go specifically to the detail view of the pool I just created, which is 34, so that I can make an update. And really, I'll just go ahead and grab this whole thing and put it in there. And really the only things that I care about changing would be pgnum and pgpnum. So I'm just going to kind of clear out the rest of the stuff.
The leader has muted your line. To unmute your line, press #6.
And so these are basically the attributes that I'm going to request an update on for these pools. I'm going to change them both to 1024, which is the recommended. So then I'm going to make a request to the API to change that. And you see again that I've got a request ID. So these long-running operations come back instantaneously. And then we can learn about what's happening with them here. And so I'm going to pause the video to talk about something specific. So you can see we're making the pool larger, and you can see the status is waiting for PG creation, and that we're making like 62 out of 900 something. So the idea here is that growing this from one shot to the other would not only fly in the face of Ceph's ability to there's a config value that says you shouldn't really produce more pgnum at this rate. So it's kind of the steps you have to take to grow this. And so we honor that config and grow the PGs piece at a time. And then we wait for an OSD map to come back and tell us that that happened. So you can see after I refresh the next time, it's going to say, okay, now we're waiting for another OSD map. And then it's going to create the next round of PGs. So the idea here is that it's basically going to be issuing a number of Ceph commands, like changing the number of PGs for the pool. And it's going to do that several different times in order to not disrupt things that are happening in the cluster. So that's completed successfully. We go back to the detail view, and we can see that the changes taken effect. So that's kind of the interaction there, and that's something that I think is really cool. And I'll go through a little bit of the code now so that you can see how that's implemented, and I can try to help you understand which pieces play which roles in the architecture. So here's another one. All right, so the place we're going to start here is in the Calamari REST API. In the URLs, there's a class called poolViewSet, and there's a number of methods implemented on that map to specific REST verbs. And the ones we're interested in naturally are get, post, and patch, and a retrieve. Those are the ones we've kind of highlighted in the video. And so I'm going to go through their implementation and talk about what happens at each layer of this as it goes all the way down to Ceph, and then how that would apply to the user story. So in the pool view set, we're going to have methods like get, create, retrieve, that sort of thing. And specifically, I'm going to show update. So this method allows for some validation that the request is well-formed JSON, and that it has all the right fields with the right kind of value types. And I'm also going to validate some semantical properties of the request, because the idea here is that since we're going to do a long-running operation and come back, we should probably check the things that we can easily check that would be an error and tell the user about that so that we don't waste their time and give them some indirection. So specifically, you can see that we're checking that the pgnum is inside the config bounds. They don't get any smaller. There's a variety of checks that we make. So once that's happened, we'll go back to the update method, and you'll see that we pass the request over to Thulu. And Thulu is a service that has the state of all the Ceph clusters it knows about in mind. Talk about how that happens. Let's see what's going on here. Okay. Yeah, I can definitely finish this in 10 minutes. So basically, the kind of thing I'm going to gloss over here is that this goes over to Thulu via RPC. And when we get into Thulu, it looks like this, where we have a request. And depending on the object type, it goes and creates this thing called a request factory. So for example, in this case, we're going to be updating a pool. We need to create a pool request factory. And then we need to check if our monitor is available to send the commands. And then we go submit them via Salt. I should be showing the request factory here. I think indeed I will. Let's see if it comes up. Right, so this is in the pull request factory, and basically this is the area in Thulu that's responsible for mapping the action we want to take from REST to the actual Ceph commands. And it makes sense of the transforms we're trying to make and turns those into things that we run on the command line, essentially on a monitor node. So the responsibility here is basically the mapping of the high-level action to the things that it actually requires in Ceph to carry it out. And then we'll see that that's this part here. I can make this a little bit faster. So we've got basically a bunch of the things that we know about Ceph, and we're trying to encode those in a way that makes sense. Let me skip ahead a little bit. Okay, so basically, once we do that, what happens is we make a request to the monitor, and we have some specific requests that live in Thulu. One is OSD map modifying requests, and it says, I'm basically changing the state of the cluster, and before I tell the user that the action has succeeded, I'm going to wait for some proof from Ceph, from Rados, that actually happened. And then there's a specialization of that, which is called PG creating request. And it's basically a state machine that says, I need to create PGs in small steps. I need to do some number of OSD pool set PG num, and wait for the right OSD map in between before reporting success. So that's kind of how all that works. And then it comes through Salt, which is a system for controlling nodes and doing config management, kind of like Puppet, but it also has another neat part. It has a message bus based on 0MQ. And we use that in Calamari. And you can see that a neat thing about it is you can just write Python modules, and you can see all the things that we have made available to make Calamari do stuff. There's a variety of pieces. We issue Rados commands. We ask for how a cluster is doing with the heartbeats. So it checks in and says things are going well. So this is really just a simple Python module, and I'll show you what it looks like right here. So the idea is, this is the module itself, and if you look for the heartbeats, I got this on video. So essentially, it's the same stuff you saw there. There's the doc string, and here's what it actually does. So I think that's really neat because you're really writing Python with no specialization. Even the parameters don't look funny. This thing doesn't take any parameters, and so when you call it via Salt, it will look like this, right? And so you're basically saying, hey, Salt, from the Calamari server, go talk to this node here and ask it about heartbeats. And then when that gets carried out, we say a whole bunch of stuff that's interesting to us in a well-formatted way. So it provides us structured data about Ceph and allows us to have all kinds of cool stuff. So let's talk about the other use case now. The one that I wanted to talk about briefly was, as an administrator of a cluster, I want to get an alert when OSDs are likely to fail. So there's a couple of ways to do that. One, you could use something like SmartMon tools, which looks kind of like this. For example, I'm going to ask for all the status of the disk SD something on another node. And you can choose to believe SmartMon or not. For some reason, I don't think it's doing so well in our lab because every disk says that it's manufactured in year 30 or week 30 of year 2002. So either we got a very consistent batch of disks, unlikely, or the RAID controller is not telling us the right information. So the idea here is that, well, you could use this tool and you could ask it to tell you when, say, sectors get remapped, which is obviously a sign that something's wrong on the disk and it has to go place the data in another area. Or maybe something in the OSD perf counters that gives you some idea that an OSD is starting to get crazy. So the idea for implementing there would be to create another module that wraps those reports and provides it via the same salt mechanism and takes it maybe over to Thulu and says, okay, Thulu's got these two different pieces. There's one called cluster monitor and one called server monitor. And basically those are just loops that watch the state coming off of salt and then send out events and do some transformations on the OSD maps and server states. So likewise, we could make a disk monitor that watches for events about disk health, and we would put the smarts of what does it mean when we get these reports of say sectors remapped via smart or some OSD perf counters, and then we could provide an implementation that looks similar to the event endpoint for Calamari. Let me make this big too. So this basically is where we see stuff like we succeeded in growing the pool, monitor join quorum. There's all kinds of messages that happen in there. There's some specific stuff about OSDs, about different domain objects of Ceph, about different things Calamari does. So we could place in there, events about OSDs, not healthy, and give it some severity that is good. We could filter the endpoint so that something like a Nagios check could come along and say, hey, API, tell me about failing OSDs. And that way we've gotten our specific information about Ceph through the channels we expect, and we can synthesize different information points and then put the pieces here to use some other tool to alert or page on. So that's kind of a whirlwind tour through what I would expect to do for something like that. How much time do we have left, Patrick?
Anytime you can wrap it up would be good.
Okay, great. So let's talk about this further. I'm going to be creating tickets in Tracker to do some of this work. I'm not sure that this is, the best idea for or the best tools, say SmartMon. So if you have other ideas about that, come and join us on the mailing list. Look at the issue tracker or send me an email. Thanks so much.
Thanks, Gregory.